And
Collagen.
that was 2. What's the third one? Reticular. Yep. So reticular connective tissue has reticular fibers. Adipose has collagen. You don't usually see it. Areolar has some collagen and elastic. We're going to elaborate on each of these as we go through. Within dense, we have dense regular, which has parallel collagen. Dense irregular, which has an irregular pattern of fibers. It always has some collagen. Depending on the location, it has some elastic, more in some areas, less in others. And then our third type is elastic connective tissue. Guess what kind of fibers? Elastic. So the big thing to watch out for in the terms is elastic cartilage versus elastic connective tissue. They both have elastic fibers, but the character of the ground substance will be different. Any questions on the classification before we go into the specific types? So, are loose, areolar, adipose, and reticular. Areolar has collagen and elastic fibers going every which way. So here the thicker pink ones are the collagen, the thinner purple ones are the elastic fibers. They don't look crinkled because when they put areolar connective tissue on a slide, they just kind of smear it, and so they all get stretched out when they get preserved. And then all the dark dots are scattered cells. Areolar is found all over the place. It's the basement membrane under all the epithelial layers. It's found in between muscles. So it holds things together and provides nutrients for epithelium. Any questions on areolar connective tissue? Adipose has collagen fibers. Often you can't really see them on the slides. Adipose tissue is found under the skin and around some organs like the kidneys, the heart, I'm going the wrong direction, kidneys, the heart, and behind the eyes, so that if you bump your eye, there's some padding behind it to keep it from hitting your eye socket. There's also some adipose tissue between muscles when there's more space there, so you need to fill it with something a little more sturdy but still flexible. So, adipose tissue stores energy and provides padding and insulation. That's all provided by triglycerides. What looks like empty bubbles here is actually the cells. The stains we use on slides generally don't stick to the lipids, so that spot looks empty just because the stain hasn't stuck. So these outer edges of the bubbles are actually the cell membrane, and you can see nuclei scattered around. So this filling up with fat also makes adipose tissue unusual for connective because the cells end up touching. Where the others are spread apart, these guys just swell up and run together, kind of like a cluster of soap bubbles. Questions on adipose? Okay. Reticular. This is the only one that uses reticular fibers. Now here's a different view of it than the fiber picture. All the lines are the fibers, and there's cells scattered around. Reticular is found in the liver, spleen, and lymph nodes, which are little oval things that get swollen in your neck when you're sick. Its function is to provide some structure, but it's not as strong as cartilage or bone. It's the reason that the spleen can be really badly damaged if you get hit hard there, is all it has to hold its shape is those reticular fibers, and they can easily be crushed. But without outside force, they hold the shape of the organ. Questions on reticular? Okay. Dense connective tissues, dense regular, dense irregular, elastic. Dense regular has collagen fibers running parallel. Often they look wavy. This is one of the few that has a poor blood supply. The fibers are so tightly packed that there's no room for vessels. Sometimes you can barely even see the cells. Where there's a few darker, short spots, those are the nuclei squished into ovals. Dense regular forms tendons and ligaments. It's places where you want a strong cord to hold things together in one direction, but you want it to be able to bend. So in your joints, where you hold the bones together, where the muscles connect to the bone, you'll have a lot of tendons and ligaments. Because of that poor blood supply, they don't heal as quickly. They don't get the nutrients to repair themselves. Questions on dense regular? Dense irregular kind of just looks like a scribble, but a tightly packed scribble. And that's the collagen going every which way. And sometimes there's elastic in there. Sometimes you can see it, sometimes you can't. Dense irregular forms the dermis, the deeper layer of the skin, and some membranes around organs such as the heart and the brain. It forms one of the meninges, and outside the serous membrane of the pericardium, there's another membrane of dense connective tissue, dense irregular. Dense irregular can protect and nourish other tissues. So because of the stuff jammed together, there's space for blood cells to come through, or blood vessels to come through. Comparing dense regular to dense irregular, think of a pack of crayons. When it's brand new, they're all neatly lined up, and they take up as little space as they can, and you can't fit anything between them. But if you put them away quickly, they end up like this. They take up more space for what they are and expand the box, and there's nooks and crannies in between them. And that's how the blood vessels fit into the dense irregular when they can't in the dense regular. Dense irregular is flexible in multiple directions. So instead of just, here's this cord that we can't stretch, but we can bend it, dense irregular is more of a sheet that we can stretch and bend a little bit in each direction. Questions on dense irregular? Our last connective tissue proper, elastic connective tissue. This one's even more tightly packed and dyed blacker, so it's hard to even pick out individual fibers, which are, of course, elastic. Elastic connective tissue is found in places where stretch is the most important. A few joints have it, like in the spinal column, instead of collagen for the ligaments. Because what you've got in your spine is you have basically a stack of cylinders, and to bend your spine, they have to kind of pull away from each other on one side, the side you're bending away from. So the ligaments need to have more stretch to them. And then organs that need a lot of stretch, like arteries, Shown here is one called the aorta, the largest artery in the body. Those need to stretch as the blood moves through and stretches them. And that's what it's for, is to be able to stretch and not get stretched out of shape. Like if you blow up a balloon and release it too many times, it's all wrinkly. Elastic connective tissue tries to resist that. Okay. Questions on any of our connective tissue proper? Okay. Our specialized connective tissues, we have 3 types of cartilage, bone, and blood. Cartilage, the general structure is a hard gel matrix, and differences in the fibers determine which type of cartilage it is. The cells get a special name called chondrocytes. Chondro is cartilage, so they're just called cartilage cells. They are the fibroblasts, the ones that build the matrix. And there are gaps within that matrix called lacunae, which is Latin for lakes, that they live in. So there's this hard matrix with little spaces for the cells. Cartilage is the other kind that has a poor blood supply. And that's because the matrix is so solid. It makes room for the cells, but not for blood vessels. This is a piece of cartilage. Sometimes you'll see multiple cells in a lacuna together, and usually that's when they've recently divided and haven't built enough matrix around to separate them from each other yet. On the surface is a membrane called perichondrium. Around the cartilage. This is another use for the dense irregular connective tissue. We'll see later that it's on your bones also. They have a coating called periosteum that's made of dense irregular. And that's where the nutrients come from, at the surface of the piece. In general, cartilage is used for structure. When you want something more flexible than bone, but still holding its shape and at least somewhat protected. The different types are, some are more flexible than others based on the fibers. Cartilage provides some protection in 2 directions. Some things it protects by being harder than they are. Like there's cartilage in your ribs that helps protect your lungs and heart. It can also protect things by being softer than they are. That sounds kind of weird, but the place where that happens is on the ends of bones. Where the bones would touch in a joint, they have a little coating of cartilage. And it's kind of like if you have a wooden chair on a wooden floor, it can scratch. But if you put rubber feet on the chair, then it protects them from scratching each other by having a little bit of give to it. And that's how cartilage can protect things, by being softer. Fibrocartilage only can also absorb shock, by which we mean physical shock, like when you step down and the vibrations go up your body. Hyaline cartilage has loosely spaced collagen fibers. Often you can't even see them. You just see a scattering of cells and this pale lavender matrix, at least with most of the stains on our slides, they end up lavender. So I don't have to add anything to the cartilage drawing to get us some hyaline. Hyaline cartilage is the one we have the most of. It's on the ends of all the bones. It forms most of your nose. So you can feel up at the top there's a small part of your nose that's bone. And then there comes a point where you can start to wiggle it. and that's where it switches over to hyaline cartilage. The sternal or breastbone end of your ribs has hyaline cartilage, and it forms supporting rings in your airways to keep them from collapsing when there's less air. So hyaline cartilage is for structure and protection. Elastic cartilage has lots and lots of elastic fibers in it. They're going every which way. They're usually purple on the slides. They kind of divert around the cells because there's no matrix in the lacuna. Those elastic fibers make the cartilage more flexible. They're found in your ears. So if you compare how flexible your ear is to your nose, that's the difference between elastic and hyaline cartilage. And it's also found in your larynx or voice box. You might have heard of something called the epiglottis that covers your airway when you